Bow, biddy, boo. Boo, biddy, boo. Bow, biddy, boo. Boo, biddy, boo. Let's see if I can share my screen with no difficulties. All right. All right. Moving around, no freezing. We're good. All right. That's what I'm talking about. Leave this here. Do a little stretching. We'll get started around 9. Ooh. Goodness gracious. Holy cannoli. Might as well listen to some music if we got it. Yeah, look at that. Just gonna turn it real quiet. Yeah, that's fine. All right. Goodness gravy. Three viewers, that's fun. Alright. Alright. Thanks for being patient. We're going to start right at 9 o'clock. So, yeah, we're just going to run through like 18 problems and mimic what the first exam will be like. Just 18 random practice problems. A couple were sent in from students as well, so that's fun. Woo. 4 viewers. Let's go. Alright. Gotta get in the zone here. I'm already tired. Woke up too early. Alright. Hope everyone's having a good morning. Hope you're not too stressed about this exam. I know it's a tricky one for the first one. But, just do the best you can. And if this one doesn't go so hot, maybe adjust your study techniques for the next one. Don't sweat it too much. There's a lot of time to bounce back. But obviously, do the best you can. Glad you're here. Glad you're at the review session. I'm just going to run through a bunch of problems and, hopefully learn a thing or two. How's this looking? Still working, not frozen. All right. Last night I was trying to do 1026 review and I had this document pulled up and the whole thing just deleted itself from under my feet, like while on the live stuff. And that was a lot of fun. So I had to just really troubleshoot in real time. Everything got disconnected. I was blessed. All right. Let's get some stretching on. Make sure to stretch. Have good posture. Don't slouch like me. Be a shrimp. Starting at 9 on the dot. Just counting down. What's that time doing? Let's see. Got 10 seconds. All right. Alright, it's 9 o'clock. Let's get started. What we're going to do today is just run through 18 different random practice problems. And they should be, representative of what you'll see on the final, more or less. I mean, they're just example practice problems. So let's see if I can spread this out just a little bit more. Doing this last night is what deleted the document. So I'm going to try. Hope that doesn't happen. Alright, I think we're good. Let's get started. So exam 1, review session, 18 problems starting now. So number 1, shout out to Max who sent me this problem over email. Let's jump into it. In this problem, they give us this crazy expression and they're asking us really to simplify it. They ask which one is equivalent to the expression. So we have to simplify all of this using properties of exponents. So for all these problems, I'm going to try to work them out efficiently, you know, as fast as I can while still trying to give some explanations here and there, but I will try to do them somewhat quickly. If you need breakdowns, most of these that I have pulled up in here are the ones that I have the videos for. So if you need more of a breakdown, you can always like revisit those videos. So let's jump into it. All right, staring at this expression here, what we want to do first is distribute this 5 to both exponents in that fraction, because the 5 is covering the whole fraction, and when we distribute the 5, we want to multiply the exponents. So 5 times 1/2 and 5 times 3. So up top, 5 times 1/2, 5 1/2 gives us 5/2, or 5/2. Let me make a smaller pen here from writing real small. So we have x to the 5/2. And on the bottom there, we have x to the 3 times 5, or x to the 15th. So that's that first fraction. And then on the bottom, let's go ahead and take care of this. When we have a 9th root, that corresponds to whatever's underneath that root raised to the 1/9. So a 9th root corresponds to an exponent of 1/9, and we keep whatever is on the inside of that root. So let me also make sure I have the chat visible in case I need it. All right, that should be good enough. All right, cool. Now we have this simplified, so let's go ahead and distribute this 1/9 to this 3. So again, if they're side by side like this, you just multiply the exponents. So 3 times 1/9, oh, that was fun. Give me just a sec. So 3 times 1/9, I'll just go ahead and write it in the next line here, is x to the 3/9. But x to the 3/9 is just x to the 1/3. And so x to the 1/3 is on the bottom. So now up top, let's talk about what happens. If we have two fractions being divided by one another, the way to simplify it is to subtract the exponent. So what we want up top is 5/2 minus 15. So we're consolidating this into a single x term, where we are subtracting the 5/2 minus the 15. All right, so we're making progress. This is what we have it narrowed down to. Let's go ahead and just use a calculator to subtract these. You don't need to worry about dealing with the fractions and finding a common denominator unless you want to. You can totally do this with just decimals. So up top, when we subtract those, we get negative 12.5. And then on bottom, we still have x to the 1/3. Now, look what we have again. We have a fraction with two x terms with different exponents. So to consolidate this whole fraction into x raised to 1 exponent, we're going to subtract these two values. So negative 12.5 minus 1/3. And when we do that in a calculator, just dealing with decimals, we get a negative 12.83, and the 3 is repeated all the way through. And so our goal is to find which one of these answer choices matches x to the negative 12.83 repeating. Now that's a crazy decimal. Let's say one thing about this. When we have a negative exponent, we can always rewrite x to the negative exponent as 1 over x to that same exponent, but that exponent is positive. So 1 over x to the 12.83. Now, when we're looking at these options, that really only leaves one possible option, or one, most likely choice, and that is this, because that's the only one that's in that form of 1 over x raised to some positive exponent. So then, if we want to check, let's just type into the calculator 77 divided by 6, and that'll give us 12.83 repeating. And that's our answer. So that was number 1. Again, shout out to Max for sending me that. Let's move on to this one. Number 2, shout out to Jack for requesting this problem, 222A. Let's jump right into it. They give us information regarding the quantities and prices of certain calendars, and they give us 2 pairs of information right away. We're going to set up 2 ordered pairs of the form calendars and price. So they tell us that they can sell this many when the price is 13. So 31, 13 is one ordered pair. 23, 19 is the second ordered pair. Now, because they say assume the demand function is a linear function, that's just thrown in there to say that we can find the slope between these two, and that will be like an accurate depiction of how the price is changing with respect to the quantity, right? So they're changing it in a linear way, in a constant rate of change. So we can find the slope between these 2 points by doing y2 minus y1 divided by x2 minus x1. So up top, we get 6. On the bottom, we get a negative 8. Now let's simplify this and rewrite it just a couple different ways. So 6 over 8 reduces to 3 over 4, and we add a negative, so I'll just tack it on there. And if we think about the context, this is the price on top changing per quantity of calendar. So it's the price per quantity that is negative 3/4. So now, more in the context of the problem, let's write it as a decimal. Because, keep in mind, we have price up top over quantity. So this is the price per quantity. So the biggest takeaway is this. For this problem, you will always get negative 0.75 for the slope between these 2 points. Every single time. It does not matter. It's just a nice pattern that shows up. So what does this mean? As quantity goes up by 1, price goes down by 75 cents. This relationship always holds in this problem. As quantity increases by 1, the price should go down by 75 cents. So now let's look at the rest of the problem. They say, what's the monthly revenue? We know that revenue is price times quantity. So what's the monthly revenue? If they set the price so that they can sell 28 calendars per month. So right away, if we know we're looking for revenue, a price times quantity, we know we need a price and we need a quantity. And they're telling us the quantity is 28. So what we need to do is find the price that corresponds to that quantity of 28. And then once we have that price, we will multiply the price and 28 together to get that revenue. So how do we do that? If we know one pair of values, a quantity and a price for which like the quantity is close to our desired quantity. So in other words, 31 is closer to 28 than 23 is to 28. So what we're going to use is the 31 information. And we're going to set up a little table. Losing room here. Let's do it down here. We can squeeze it in. What we're going to do is make a little table with quantity and price values. And we're going to start with what we know, and we're going to work our way to what we need. So 20, I'm going to still put them in order though. So 28, 29, 30, and 31. Yeah, I'm sorry, this is in the way. Let me go ahead and move this. I think I thought I'd be writing smaller. I was mistaken. All right. So again, we have quantity here, we have price here. What do we know? We know that when the quantity is 31, the price is 13. So we know the price is 13. And our goal is to find this price up at 28. How do we do that? Well, if we know that as the quantity increases by 1, the price should be going down by 75 cents. Well, let's think in the opposite direction. If the quantity is going down by 1 from 31 to 30, then the price will do the opposite. So as quantity goes down by 1, price should go up by 75 cents. Again, this slope of negative 0.75 and like these relationships that are boxed off here will always hold true for these problems. So if you wanted to, you could always like skip this step and just, skip the first step and then jump right to the chart here. Okay, so starting here, if we're going back in quantity or down in quantity, this price should be going up by 75 cents. So we should have $13.75, and if we keep going, we're adding 75 cents again. So $14.50, add 75 cents one more time, and we get $15.25. So that's what we're looking for. We're looking for the price that corresponds to 28. Why did we need that price? Again, It was because we needed the price that corresponded to 28, so then we could multiply these two values and get our revenue, because they're asking for the monthly revenue. So doing this in my phone, 1525 times 28 gives us 427. So that is option C. We break out the eraser to see that C is our answer. All right, I think I've said enough about this one. Let's move on to number 3. Shout out to Trevor for sending me this problem. I don't have, the answers, so we're starting cold here. Let's jump right into it. In this problem, something huge that we see in a couple different problems is how they ask this question here. They start with, what is the least number of smartphones? So right away, what we know is that we're solving for a quantity. All these are potential quantities that could be our answer. We're solving for Q. So if we're using any equations that have Q in them, for example, revenue, and for example, cost, we are not going to plug anything in for the quantity in those equations because we are solving for Q. So when they give us this, they're throwing us off. They're just saying they are currently manufacturing that many, but then they ask how many do they need to sell, or how many must they produce to sell them for this much and earn a profit. So always ignore that first quantity. You don't plug that in because we're solving for Q. All right, we're solving for Q, and we want to know what's the least quantity for which you actually earn a profit. So what's the quantity you finally produce for which the profit goes from a negative, or you go from a loss into the positive profit, into earning a profit, right? So from negative to positive, crossing that break-even point, essentially. So profit's the key word. We want to find the profit. Profit is revenue minus cost. And we know revenue is price times quantity, and we will use this cost formula here, variable cost times quantity plus fixed cost. Sorry if my mouse has just been floating in the way. Just oblivious. So we're going to set up the revenue, and we're going to set up the cost, and then we're going to subtract the two. So revenue is price times quantity. What's the price that they're selling the smartphones for? They will sell the smartphones for $97 each. That's our price. Again, anytime we see quantity, we're going to leave it as Q because we're going to solve for Q. Cost, variable cost. What did they say? The variable cost is $80. Variable cost times quantity, so 80 times Q, and then plus the fixed costs, which are up here, 646. Just like that, we have our revenue, we have our cost. Now we want to find profit. Revenue minus cost. So the revenue doesn't necessarily need to be in parentheses. However, I highly encourage you to put the cost in parentheses, because if you're subtracting the cost, this negative needs to get distributed to those cost terms. So when we distribute it, we have minus 80Q minus 646. Again, the negative gets distributed. We can combine these like terms, and what we get is 97 minus 80 should be 17Q minus 646. So this expression, now that we have it here, now that we have it simplified, is our profit. So what are we trying to do? We're trying to find the quantity for which we finally earn a profit. So what's going to help us is first finding the quantity for which the profit equals 0, for where we break even, in other words. So what we're going to do is set this profit expression equal to 0, and we're going to solve it for Q. So I know I'm impeding on this next problem here. I'm going to have to keep sliding problems back, but I'm going to keep it light so I still have room for the next problem. All right, so we've set the profit equal to 0. We're just going to solve this for Q. So adding 646 and then dividing by 17. When we do that, we get, I don't know, let's see, 646 divided by 17, we get 38. Sorry for that school bus or the trash truck. Thing is loud. All right, so what's important about 38? Is this our answer or not? This is the quantity for which the profit was equal to 0. This is where we break even. So if you ever get a problem that asks about, what's the quantity for which you break even? we would find the profit, set it equal to 0, and solve for Q, and we'd be done. But they don't ask us where we break even. They want to know where we actually earn a profit. And so if this is the quantity for which the profit is equal to 0, all we need to do is produce and sell one more. We just add 1 to that quantity, because then that'll push our profits into the positive amounts. In other words, we will earn a profit. And so 39 should be our answer. Sometimes they will include both 38 and 39 to throw you off, but in this case it does not look like they did. They just threw in the 38. So when in doubt, round up. That's pretty much it. Let's move on to the next one. This is a classic. I'm so glad he sent me this one. For this, let me see if I can like shove these down, because these do not need to be big and bold. Let's see. All right, we need our space for this airline problem. This, I would bet, 98%. This 90, I would bet a lot of money. This is going to be on the exam. So, in this problem, they say for what value of the ticket price T, so we're solving for T, will the airline's profit, keyword profit, be maximized? We'll talk about the maximize in a minute. We're basically going to find the profit equation. That's the majority of the problem. And then find where that function or that equation is at a maximum. Okay, so profit, again, is revenue minus cost. Revenue, still price times quantity. Cost is still variable cost times quantity plus fixed cost. But here's the catch. The price, the p-value here, and the quantity here and here is a little strange, or they're represented in strange expressions in this problem. So what we're going to do is lay out what each of these constants or things will be represented as. So we're just going to lay them out here to break up the problem a little bit. So the price is the selling price, the price that we're selling the tickets for. So that price will be represented by T. That's it. Every single time the price of the ticket is T. And again, we don't know the ticket price because that's what they're asking us to solve for. So that's why we don't plug in a number. We don't know it. And then the quantity. Here's the real weird part. Then they can expect this many passengers. So that whole expression, 250 minus 0.67 T, is your quantity. All right, those are the two weird parts. Hopefully the rest is not too bad. The variable cost is the cost per passenger. It's the cost per quantity. So that's 65. And then the fixed costs are always 4,000 in this problem, every single time. So we have all we need to plug in to the revenue and the cost. We'll simplify each of those, plug them into profit to find the profit. That's going to be the majority of this problem. So that's what we're doing next. Revenue, price times quantity. What's the price and what's the quantity? T times 250 minus 0.67 T. And I highly recommend going ahead and distributing the T here and here. 250T minus 0.67 T squared. This is our revenue, and that's an odd 7. There we go. Now we find the cost. Cost, looking up here, is variable cost, so 65 times the quantity. Again, the quantity is right here. We still plug in this entire strange expression wherever we see Q. And then we tack on the fixed cost of 4,000. Again, let's go ahead and distribute the 65 to both these, and then we'll tack on the plus 4,000 to the constant term. All right, so 65 times 250, we get 16,250. 65 times 0.67 with a negative, we have minus 43.55, and that has a T, and then we have plus 4,000. So the last little step for the cost is going ahead and combining the 16,000 and the 4,000. So that should be 20,000. We're going to do 20,000 and 250. So that's these two terms added. And then I'll bring the T term out in front, just to keep these in somewhat of an order. So a little sloppy there, but negative 43.55t plus 20,250. We have our revenue, we have our cost. Now we subtract the two to find the profit. Profit is revenue. Use a slightly different color here, so 250t, this is our revenue, 250t minus 0.67t squared minus the cost. Here's the important part. Cost is in parentheses. All right, we have revenue minus cost. This negative gets distributed to both these terms. So when we rewrite it and simplify it, we have negative 0.67t squared. I'm going to do plus the 250t, so swapping those places. And then distributing the negative, we get a plus 43.55t and a minus the 20,000 value. So all that's left to do here is to combine these. Let's see if I can white out this space here just to like not distract us. So we just want to add the two t terms together. Let's do that real quick and write the profit over here. So we'll get negative 0.67t squared plus 250 plus 43 is 293.55t, and then I'll just say plus, I'll just do minus c. So this constant really doesn't matter, and I'll talk about why. This is our profit expression. We're more concerned about the t squared term and the t term. Here's our last step. We have our profit. We want to know the t value for which the profit will be at a maximum. Roughly put, because this is a negative t squared function, the graph will look like this. This is the vertex where the max will occur. We are finding the x value or the t value where that max occurs. And there's a nice little equation that helps us find the vertex of any parabola, and that is negative b over 2a. So we are finding that x value, in other words, finding that t value by looking at these. This is our a value, and this is our b value. So this comes from like a quadratic form, ax squared plus bx plus c. So we're just going to calculate this. So writing it out, it'd be like negative 293.55, so negative b divided by 2 times a. So sorry to zoom in if you're still getting the other stuff or whatever, but I'm just trying to write neatly here so it's legible. So 293-ish divided by 2 and divided by the 0.67. So calculating this, we get about 219 equals t. And we're done. What the heck was that? All right, hopefully something good. Sorry if that blew out some ears. Like right when I finished, popped up. All right, 219 is t, rounded to the nearest $5. 219 should be equal to 220. That's our answer. That was number 4. That was one of the harder, more important problems that I would promise should be on that exam. If it's not, you got lucky. Great problem. Thanks for sending that in. Again, shout out to Trevor. Let's move on to number 5. Let's see if we can navigate looking at this without getting distracted from the other stuff. All right, let's keep it going. In this problem, they give us a function, and they ask, what is the value not in the domain? All right, domain, hopefully x values come to mind. Specifically, domain is the set of x values for which when you plug them into the function, you get a defined function value out. So in other words, if you plug in a value, an x value, that's not in the domain, what would happen is you should get an undefined function value. Well, what leads to something being undefined? Typically, it's when you have anything, so I'll just say x, it's if you have anything divided by 0. So in other words, when the denominator is 0, that's when something is undefined. So to summarize, we're looking for the x value that makes the denominator equal to 0. So I'll leave it up to you. You could plug and chug these options into that denominator to see which value here gives you 0 in the denominator, or you could factor the denominator. So that's my approach. I'm just going to write it out and factor it real quick. So we set it equal to 0, and then we're going to factor it to help us find the x values that actually make it equal to 0. So we have x, we have x. We're looking for two numbers to multiply to 14, but add to positive 9. So that is, God, am I writing? Plus 7 and plus 2. 7 times 2 is 14, and 7 plus 2 is 9. When we set each of these equal to 0 and solve, we sort of get the opposites of what you would see in the factors. So you might memorize it as like if you see x plus 7, the answer, the solution is -7. And then if you see x plus 2, -2, right? So these are the x values that are not in the domain because they make the denominator equal to 0 if you plug them in. So which one of these answers do we see? That's right, D. So D is our answer. They will always throw in the opposite of this one. So like if it's -2, they throw in +2, and they do that to throw you off, so be very careful with those. Again, you can just plug and chug the value, see which value makes the denominator equal to 0. All right, let's keep going. Number 6, here's a nice one. They ask which of the following equations describes the line that contains the point -2, -3, and has a slope of 8. So going back to algebra stuff, really, when we're given a point and a slope, you could use one of two formulas. You could use point-slope formula. That is this one. And so if we follow these guidelines here, this is x1 and this is y1. Plugging those values into this equation or into this format, we would get y minus -3 equals the slope of 8 times x minus -2. And sometimes you might actually see this in one of the answer choices. They might they might take care of the double negatives to make it like y plus 3 and then x plus 2. But you might see this as your answer and you might be done. But in this case, obviously, most of the answer choices are in y equals mx plus b form. So if we're already at this step, let's just go ahead and solve this for y and simplify the right side. So let's start by distributing the 8 over here. We get 8x plus 16. And then getting y by itself, we would just subtract the 3. So 16 minus 3 is 13. So we get 8x plus 13. So if you prefer that method, that'll work. Briefly, I'll talk about y equals mx plus b. If you wanted to, you have an x, you have a y, and you have an m. So if you plug these values in to their respective places and y equals mx plus b, this will allow you to solve for b. So if we solved for b here, I won't talk about the details, but we get -3 plus 16 in the end. And that would tell us that b, or sorry, I just messed that up. No, so -3 plus 16 is correct, but that would give us 13. So b would be 13, and then that would help us see that a is also the answer. So two approaches to that one. Hope that helps. Let's keep it rolling. Number 7. Which of the following is true about this function? All right, 2 steps. First step, look at the leading term, the x squared term, and really just identify whether it's positive or negative. If the 4 is positive, which it is, this x squared function, this parabola, will open up. So a positive x squared opens up. Had it been negative, it would have opened down. Now what's the significance? If it's a positive x squared, its vertex is the minimum value, or that's the location of the minimum for that function. Because these values shoot off to infinity, there will be no max for that function. However, if you have a negative x squared where it's opening down, you will have a max at the vertex. So it's basically positive x squared min negative x squared max. So we have a positive x squared, so we should have a min, so we can eliminate any that say max. That leaves us with b and c. Now what's the only difference between b and c? We look at their x values. Those are the same. but the y values are different. So briefly, let's talk about how to find the x values, how to find that 3, and then we'll talk about how to find the correct y value. The x value thing is something we mentioned earlier in the plane ticket problem. We said to find the x value, or in the other problem is like to find the t value, so the location of the vertex, how we find it is by doing x equals negative b over 2a, where 4 is a, b is negative 24, and c is 77 over 2. You don't really need the c, but yeah, just for reference. Negative b over 2a, we'd get negative 24, and then divided by 2 times 4. So we have a positive 24 divided by 8, and that is 3. That's where the 3 comes from. So now, with any situation, if you know the x value and you know the function, and you're trying to find the y value that corresponds to that x value, just plug in the 3. Just plug in that x value to the function to find the y value. So plugging in 3 for x here, let's just go ahead and work it out roughly here. So 4 times 3 squared, that's 4 times 9, or 36. I'll just do like most of it here and then type it in. So 24 times 3, so minus 24 times 3, I think that's 72, and then plus 77 over 2. So, you can just type all this into a calculator. You didn't have to do anything I just did. So typing all that in, it looks like we just get a nice, if I did that right, 2.5. So 2.5, we're looking at either 77 over 2 or 5 over 2. So if we wanted to check, we could do 77 divided by 2 or 5 divided by 2. And hopefully we recognize that 5 divided by 2 is equal to 2.5. So that is the y value that corresponded to an x value of 3. All right, let's keep it going. Number 8. This is a fun one. Let's talk through the efficient way as best as possible. Let's talk through it. The first thing we're going to do is take care of any coefficients out in front. I'm talking the 4s and I'm talking the 2s. Our goal with this whole thing is to simplify it into a single natural log. Currently we have 3 natural logs across the board there. So first up, I'm going to leave the negative on the outside, but I will bring the coefficient up, and what happens is the coefficient becomes the exponent. So we brought this 4 up and it became the exponent of the inside t squared minus 4 inside that natural log. We do the same thing with the second term. The 2 comes up, so we have plus ln of t minus 2 squared. And the last one has no coefficient to worry about, so we just leave it as is. Now my next step, any term, so our next step is just going to be to condense everything into one big natural log. This natural log will always have a fraction. It'll be a quotient, numerator, and denominator. Any terms that have a negative out in front, we'll send that expression, whatever's inside its natural log, that will be sent to the denominator because of the negative out in front here. Any terms that have positives out in front, we'll send these 2 expressions to the numerator. So we'll have t minus 2 squared and then 5t over 2 in the numerator there. These will technically be multiplied within that numerator. Now, we've done what they asked us to do, and that is write it in a single logarithm. But they will always give us these problems where we have to simplify it even further. And it's like annoying, but the nice thing is that it's always like in the same format, so you'll always do the same thing in terms of simplifying. The denominator can always be broken up, can always be factored as a difference of 2 squares, like in that method. So we see t squared minus 4, and t squared minus 4 can be broken up into t plus 2. I'll start with t minus 2 actually. It can be broken up into t minus 2 and t plus 2. So what we've just done is factored this into its plus and minus factors. So, and that comes from a difference of 2 squares. It's a helpful factoring method for certain situations. So then the 4 on the outside, because t squared minus 4 was raised to the 4th, that means both of these factors down here will also be raised to the 4th. And then we still just have what was left up top. Now we simplify. We can cancel out a certain number of certain factors. T minus 2, we have 2 t minus 2's up top. We get rid of them while we get rid of 2 of the 4 on the bottom. So because we got rid of 2 on top, 2 on the bottom, we are left still with 2 of them on the bottom, right? So we get rid of these, we get rid of the 4, we're left with 2 of them, and this should pretty much be it. What you'll see them do is this 2 on this denominator, they'll throw it into the big denominator. That's kind of just like a simplifying situation. So we still see 5t over 2. It's just kind of broken up like that. So we're looking for a 5t on top, which looks like only one of them. And then we see the 2, t minus 2 squared, t plus 2 to the 4th. I hope I said all that right. It looks like C is our answer. What on earth is that? Someone's spamming the chat? All right. Holy cannoli. Can I block this person? All right. That's super cool. Just gonna hope that doesn't keep popping up. That's super annoying. All right. I'm just like a small chat. Why is that happening? All right. Number 9. Let's keep it pushing. Someone block that person or something if that's possible. All right. Number 9. In this problem, they give us a function. This is known as a piecewise function. Just looking at the chat, it irritates me. All right. Piecewise function. We're given a function with 3 different pieces. So one graph is made up by 3 different graphs, basically 3 different functions. So let's talk about how to approach this in an efficient way. Starting with these over here. These are the intervals for which these different pieces are defined. And the important pieces are this. If you have x less than or equal to 4, x is less than or equal to 4 is describing the leftmost piece of these graphs. And because it's less than or equal to, the equal to is what sends these dots, these open dots, to have a closed dot. So when it's an equal sign, we want to look for the closed dot like we see in A and B, and not these open dots for those segments like we see in B and D. So we have A and C narrowed down, and we can also check, all these other ones here. So like this middle segment, 4 is less than, x is less than or equal to 6. That means the less than is the open dot at 4, and then less than or equal to is the closed dot at 6 for the middle section. And that holds for both graphs. So typically, once you narrow it down to 2 graphs, then you have to take the next step, really. That next step is looking at A and C and asking yourself, well, what's the difference between these? And 100% of the time, it's going to be something about that middle section. The middle sections are usually the flips of one another, the opposites. And so what I recommend, sometimes there's certain ways you can look at the coefficient, an important coefficient of this piece, and say is it positive or negative? That'll help us pick blah blah blah. But what I would recommend instead, if you're not comfortable with analyzing big functions like that, because it's kind of a nightmare looking at that middle function here, what I would recommend is pick an x value that's in between 4 and 6. So what are we going to pick? We're going to pick 5. X equals 5, and what we're going to do is plug it into this piece. And what that's going to do is give us a y value. And we can tell which graph will be the correct answer depending on whether that y value is positive or negative. And so plugging in 5 to this x value here, I'm calculating this. I'm just going to do this in my phone real quick. We will have 5 minus 15 over 4. That's 1.25. And then we're going to square that. And then we're going to multiply that by 1/36. We get this small decimal, it's still positive, and then we tack on this plus 1. and that keeps it positive. So we get like 1.04 for that value. Regardless, it's a positive 1. So what we found is that when we plugged in x equals 5, we got a y value from the function of 1.04. And 1.04 is positive, so we're looking at A or C. Well, A at x equals 5 has a negative y value, and at C at x equals 5, the y value is a positive 1-ish value. So C is our answer. Let's keep it rolling. Number 10. Here's a great problem. There it is, cleared up. In this problem, they ask us to write the monthly cost as a linear function. And then once we have that, we'll plug in 500. Let's talk about the linear function first. A linear function, the first thing that comes to your head might be the equation of a line, y equals mx plus b. You can think about it like this, but what I might recommend is just not overthinking it, because what's the cost function that you know already? When I say what's the formula for cost, you might say, well, it's variable cost times quantity plus fixed cost. And if we think about it, variable cost is like the cost per quantity, or a rate of change of cost per quantity, which is very similar to the slope. The x is like q, it's like a quantity, and then the b is a y-intercept. The b is like your cost when you're not producing any quantity at all. This is the connection to the linear function. So the cost function you already know is your linear function. So that's all they're asking you to find. So don't think too hard about like y equals mx plus b. Just think about this. Okay, so we need to find this function. What's important about this function? Well, we need the variable cost and we need the fixed costs. That's our goal. We want to find those two values. Fixed costs are given to us right off the start. Fixed costs are $35,250. All right, so we have our fixed costs. We just need to find our variable costs. Once we have those, then we'll plug them in here, and then we will have our linear function, and then we'll plug in the 500 for this q, and that'll help us calculate this cost, right? So finding the variable cost, unfortunately, is a little more involved, but let's talk through it real quick. They give us some more information. They say that when 1,500 lamps are produced, the average cost is $37.50. And they tell us that cost equals average cost times quantity. That is an additional cost formula, which it could not hurt to know. It's really it's like the plan B, basically, of cost formulas. This is our main one, and then that's like your backup. So make sure to know both of them. Couldn't hurt. So we want to use that cost equals AC times Q to find a specific cost, right? So when we plug in these specific average cost and quantity values, it's not going to spit out some function. It's going to spit out some specific cost value. So 37.5 times 1,500 gives us, did I do that right? I'm going to try it one more time. 37.5 times 1,500. We get 56,250. All right. So again, this is a specific cost. I keep saying that. Let's talk about what I mean. It's a cost that corresponds to a specific quantity. In other words, it's giving us basically an ordered pair. When the quantity is 1,500, the cost is this 56,000 value. So quantity and cost is almost like your X and your Y. So what we're going to do, with what we know the fixed cost, we know a Q, and we know a C, a specific pair with the fixed cost. We can plug these values accordingly into this equation, our linear function, and we will be plugging in a C, a Q, and an FC. That will allow us to solve for VC, variable cost. So that's what we'll do next. So setting this equation up with our specific values will look like this. The cost on the left side is 56,250. Use a little thicker pen here. 56,250. Variable cost we do not know. the quantity that corresponds to that cost is the 1,500. And then we add on the fixed cost of 35,250. Our goal here is to solve for the fixed cost, or sorry, the variable cost. We're going to subtract the 35,250. What was that? 21,000. 56,250 minus 35,250. We get 21,000 equals variable cost times 1,500. So we get variable cost by itself by dividing by 1,500. And we get this nice value of 14 for our variable cost. Now we have our variable cost of 14. We have our fixed cost of the 35,000 value up here. So we have what we need to construct this linear cost function, or 14Q plus 35,250. That's our cost as a linear function. So now, once we have that, we are just finding the cost of producing 500 lamps. So we will just plug in 500 for Q. And calculate this cost. So 14 times 500 plus 35,250 gives us 42,250. So 42,250 is the cost that corresponds to a quantity of 500. All right, so that's our answer. So again, we found the fixed cost. It was given to us. We set up the average cost times quantity to get that specific cost of 56,000, which corresponded to that quantity of 1,500. We plugged in those three values here, here, and here in this equation, and that allowed us to solve for variable cost. Then we plugged in the variable cost, the fixed cost, and the 500 into that equation to solve for the cost. All right, let's keep it rolling. Number 11, here's a nice easy profit problem. This is a great base one to start with if you're not familiar with profit, which hopefully you are by now, but you never know. They ask us to find the weekly profit if we sell this many bobbleheads. So profit is revenue minus cost. Revenue is price times quantity. You know what cost is, variable cost times quantity plus fixed cost. So let's jump right into it. This is a version where, because they're asking for the value of profit, which is revenue minus cost, what that means is they should be giving you all the information to just plug in all these values directly and just calculate a number for the profit. So revenue is price times quantity. What's the price that we're selling them for? $17. What's the quantity? They're selling 13. 17 times 13 is 221. That's our revenue. All right, so for cost, we need a variable cost of $7 times the quantity, which is the same, 13, plus the fixed costs, which are 55 per week. 7 times 13 plus 55 gives us 146. That's our cost of production. And so if we made 221, but it costs us 146, then we find our profit by just finding that difference, revenue minus cost, and we get $75 profit. So again, that's just following those three main equations for profit, revenue, and cost, and plugging everything in. All right, let's keep it rolling. This is a good one. So in this problem, I actually wanted to go through showing you how to do this in Excel. So let me flip this around here. That's fun. And then let me open up Excel. I should be able to share it while I'm sharing the other thing. So we're going to move this and, oh gosh, wrong one. Holy cannoli. There we go. All right. Excuse me. All right, so we're just going to jump right into it. What we're doing is plugging in these values in Excel. You could put the prices in the first column and the revenues in the second column, but you could also just type it in as you see it. So 5, 6, 8, 9, 11, 14, and then very carefully plug in these values like you see them, 177.9, 204.5, and so on. Sorry if I'm like pounding on my keyboard right now. I often forget my mic's on my on my desk, so it might come through a little rough. Sorry. All right, hopefully that's straight. I think that's it. So we input the data, and what they want us to do is insert a scatter plot. So we go to insert, we go to charts, we go to scatter. This will do just fine. And now they say something about fitting an appropriate trend line. Every single time you get this problem, just use this same method. So what we'll do is double click on the title, like white space here on the chart. So double click here. That'll open up this add chart element. We'll add chart element, go down to trend line. We're not doing a linear trend line or a line of best fit. We want to open more options. We have to click on this bar graph thing, trend line options, and we go down to polynomial of order 2. What this is doing is not fitting a line of best fit, but more of a curve, like a polynomial or a parabola of best fit. So like an x squared function of best fit. That's why it's a polynomial order 2 for x squared. Then we display the equation on the chart. So we have this equation. Trying to spread it out. It's not letting me drag these arrows. Oh well, I'll just put it up here. So now this is our function that's relating the price to the revenue. The price is x, revenue is y. Now looking back at the problem, they tell us that use your model. Our model is the equation we just found. Use your model to estimate the revenue if the price is $12. So all we do is plug in 12 wherever we see x. So I'm just going to go ahead and perform this in Excel. So we're typing in this equation with was it 12? Yeah, with 12 plugged in for x. Negative 1.4 times 12 squared. Yeah, plus 42 times x, or 42 times 12, plus 2.9. And when we do that, here's the function again if you need to reference it. When we do that, we get 305.3 or 305 and 30 cents. So we're looking down here. I have to move back to the iPad now. And we get option E. Oh, goodness gracious. Sorry. Twisted everything around. 305.3. I hope those make some sense. I'm going to get out of this and just keep it moving. Again, if you need more of a breakdown, you can always check out the video for that. But for time's sake, I'm going to keep it rolling. Let's make sure. All right, I'm going to hope this doesn't exit out the whole thing. I'm going to make this larger. All right. Make sure I can see the chat in case anyone needs to ask anything and not spam anything there. All right, that's good enough for me. Let's keep it going. Number 13. Starting with the last question they ask, they say, what is the expected monthly revenue? Keyword, revenue. We know revenue is price times quantity. So to find a revenue that they're asking for, we are going to need a price and we are going to need a quantity. They tell us we're selling 200 tickets. That's our quantity. So we just need a price to go along with 200. All they tell us is that P is equal to that equation or that expression, where P is the price and Q is the number of people who buy tickets, yada, yada. So we need to calculate a price by plugging in a specific quantity. Well, we know that the quantity is 200, so we're just going to plug in 200 in here, and that'll give us a price. So 289 minus 0.002 times the quantity of 200. So calculating this real quick, should not be far off from 289. We're subtracting a pretty small number. And this gives us 288.6. Again, this is not our answer. This is our price. This was the price we needed to plug into the revenue equation. So price is 288.6 and the quantity is still 200. So now we just multiply these two. So 288.6 times 200 gives us a revenue of $57,700. 720. Good enough. All right. And that's it. That's a nice quick one. They ask for revenue, so we know we need a price and quantity. Quantity's given. We have to calculate the price by plugging in that given quantity. Then we multiply price and quantity. Let's keep it going. Number 14. Here's a great problem. I'm going to try to work it out efficiently as possible. They're giving us a lot of information regarding the prices and the amounts of donuts. They're giving us information so that we can set up ordered pairs. So the price is like the X and the number of donuts is like the Y. They give us information regarding the demand and the supply and, you know, different ordered pairs. And the goal is to set up a function, a linear function, both for demand, so like one for demand and another function y equals mx plus b for supply. So demand, supply. We're going to first identify all the ordered pairs that they give us. So starting with demand, they say when the donuts are given away free, they can give away $2.25. So first ordered pair, the price is 0 or free, number of donuts $2.25. Demand drops to $1.50 when the price is 25 cents. So we'll do 25, comma, 150. If you wanted to, you could do 0.25 because it's like, 25 cents, but you don't have to. I think it's much easier to just keep everything in the units of cents. Okay, so we have our two ordered pairs for demand. Let's go ahead and find the ordered pairs for supply. They say they can supply 50 donuts. Let's use a different color. Let's use supply 50 donuts free of charge. So again, 0, comma, 50. But then 50 cents is 150 donuts. So 50 for the price and 150 for the amount. So we have these two ordered pairs. As long as you have 2 points, you should be able to come up with the equation of a line. So that's what we're going to do for both of these. Starting with the demand. Finding the equation of a line, we are going to do the slope formula first. So y2 minus, need more space here. Let's see. y2 minus y1 divided by x2 minus x1. Up top we get negative 75. On the bottom we get 25. Thinking in terms of quarters, the coin, a quarter. 75 divided by 25 is 3. So 75 cents, it's 3 quarters. So negative 3 is our slope. Now the b value, the y-intercept of y equals mx plus b, is always found by looking at the ordered pair that has an x value of 0. If you think about like a y-intercept on a graph, it's always where the x value is 0 and the y value is whatever the y value is. And so what I'm getting at is this ordered pair tells us the y-intercept, just like that. B is equal to 225. That's where we get our B, is by looking at the y value of the ordered pair that has the x value of 0. Setting up our function now, we have m, negative 3, and b, 225. Y equals negative 3x plus 225. Now, let's see if we can spread out a little bit and do the same thing, but with the supply ordered pairs. I'll talk about what to do once we have these. So again, we're finding the slope, y2 minus y1 over x2 minus x1. We get 100 on top, 50 on the bottom, and that is what, 2. So we get a slope of 2, and our b value again comes from this ordered pair with the 0, so b is 50. Our equation is 2x plus 50, mx plus b. This is for demand, this is for supply. They ask, what price or what value of x should they charge so that there's neither a surplus nor a shortage of donuts? In other words, we want to know where, what the price is for which the supply will equal the demand. So we're going to set the demand equal to the supply and solve for x. So we're going to start with, let's go ahead and add the 3x over here. We have 5x. Simultaneously, let's subtract 50 to the other side. 225 minus 50 is 175. And just like that, we have this tightly packed equation. 175 equals 5x. We divide by 5 on both sides, and we get x is equal to 35. And that's it. 35 cents per donut is our answer. All right, hope this makes sense. For time's sake, I'm just going to keep it pushing. We have a few more to get through. And yeah, all right. In this problem, they give us information regarding a first price and a second price, and they give us information regarding the elasticity. So I would highly recommend knowing this one equation for the elasticity, and that is elasticity is equal to percent change in percent change in demand over percent change in price. All right, so what are they asking for? They say what will happen to the demand, and then they're saying stuff about the demand will decrease by certain percentages. In other words, we are hoping to solve for the percent change in demand. So hopefully they've given us enough info to find the elasticity and to find the percent change in price. And they have. Let's talk through it. To find percent change in price or percent change in anything, so I'll say percent change in P, I'll do price. What we need is new price minus old price divided by old price. So we're finding so let's start with change in price is just the difference of the two prices. But percent change in price, they're wondering, like, how is it changed relative to what it was initially? That's why we divide by the initial price, the P1. So P2 minus P1 divided by P1. You could multiply by 100, but I would not worry about that in the majority of these problems. That's sort of an afterthought. I would just keep everything in terms of decimals when you're dealing with these problems. So P2 minus P1 over P1 is what we want to calculate. So the P2 is 92.40, P1 is 88. So 92.4 minus 88 divided by 88. This will give us the percent change in price. And when we calculate that, we get percent change in price is equal to 0.05. Again, that would be 5%, but I'm just going to leave it as a decimal within these calculations. We're going to plug in 0.05 into the percent change in price. And then, because they give us the elasticity is -2, we're going to plug in -2 for the end value. So -2 equals percent change in demand divided by percent change in price, which is 0.05. We solve for percent change in demand, or we get it by itself by multiplying both sides by 0.05. So -2 times 0.05 gives us the percent change in demand is equal to -0.1. In other words, -10% if we multiplied it by 100. So -10%, or a decrease by 10%, is what we were looking for our answer. All right. Hope that makes some sense. I'm going to drink a little water, and we're going to move on to the next one. Just a sec. Right. Number 16. In this problem, they give us a huge statement. They're basically just saying this is cost, profit, and revenue. And then those with the M in front just mean marginal cost, marginal profit, and marginal revenue. We can sort of ignore everything except for these three values. I'll try to box that off a little nicer. All right, so we're looking at these three equations, rather. So they give us three statements, and we're just trying to, analyze these statements and reference these three equations to verify their accuracy. Number 1, the number of books published and sold from 450 to 451, the total profit. So right away, profit, we're looking not at MC, not at MR, but we're looking at MP. So marginal profit, when they mention profit, they say if it increases from 450 to 451, which it is starting at 450, so like that is a true statement, like so far, profit will increase by approximately $4.30. That is not what the marginal profit equation says. It says 0.8. So this is a false statement. So if you're wondering about like the 450 to 451, it's not negligible, but like it wouldn't make it wrong. So the only thing that makes the statement wrong is the 430. Had it said increase by 80 cents, that would be correct. Why is this correct? Marginal profit equals 0.8 is telling us that the profit will increase by 80 cents if the quantity were to increase by 1. In other words, the profit per quantity is 80 cents. All right. So really, we're really just checking if like it matches the equation. So this one did not, and so we move on to number 2. Number 2 says when 890 copies, the total cost, so we're looking at marginal cost, is increasing at a rate of $4.30. So we do see 890. We do see increasing at 430 because this is a positive 4.3 or $4.30. So the cost should be increasing by 430 per quantity. So had they increased the quantity from 890 to 891, the cost should go up by $4.30. Number 3, if the number of books published and sold increases from 450 to 451, then the profit, we're back to this one, marginal profit. Marginal profit will increase by approximately 80 cents. Look at that. That's exactly what we said a moment ago would have made the first statement true. So that is a true statement. All right. Not going to talk anymore about this one. If you want more of an explanation, feel free to check out the video on this one, but hopefully that suffices for now. Let's move on to number 17. Now here is where that one little, good question. Let's see. Will I get the same answer if I multiply by 5? She was probably asking that about something back here. Let's see. Yes. You know what? Technically, yeah, you would get the same answer because you would have had everything in terms of percentages, if that makes sense. So like we could have plugged in, sorry to sort of backtrack and go back to this, but I'm just seeing your question here. So instead of plugging in 0.05, technically, yeah, you could have plugged in 5% and then multiplied this over here to get negative 10% for percent change in demand. The reason I mentioned like just using the decimals is because like in this problem it's fine to use the percentages, obviously, like you just asked and like we just showed, but there are some other problems where you have like multiple steps with like plugging certain values in, and it seems to simplify things if you keep them as decimals. But in this case, yes, you totally could have multiplied by this 5% to get that 10 or negative 10%. Great question. So checking out this one. Earlier, if you were with us, I mentioned something about there's the regular cost function, variable cost times quantity plus fixed cost, and then there's sort of this backup function that you sometimes see that could not hurt to know, and that to produce Q coffee makers is this. This whole expression is your average cost. Then they give us this selling price, and then they, like, that's it, and then they just ask us to find the profit function. Okay, well, profit is revenue minus cost still. Nothing's changed. Revenue is price times quantity. So we can probably find that. Because we see Q's in the functions, that kind of helps guide us to say that we won't plug anything in for the quantity. We're just going to leave quantity as Q in all of these expressions. So for the revenue, the price is the selling price of 57, and then the quantity is Q. 57Q is our revenue. Now to find the cost, again,